Okay, today we start chapter 4, which is on applications and derivatives.
Yes. After we go over the test.
So we should know how to compute derivatives, but now we're going to use it to solve problems.
That's it.
Okay, today we're going to find maximum and minimum points on a graph in calculus.
Wait, we're gonna.
No! We always get it back at the end. Okay, suppose you have a graph that looks like this.
That's not continuous.
It's continuous from there to there.
It's not differentiable.
Yeah, well, I'm just saying, this is a graph. Okay, how do you classify this point right here? Come on, this is like
Local maximum.
that's called a local maximum. Compared to points nearby, it is the highest point on the graph, but it's not the highest point on the entire graph. So we call this a local or a relative maximum. Either one, local or relative. What about this point right here?
It's the minimum.
That's the absolute minimum, because that's the lowest point on the entire graph. Absolute minimum. What about this point?
Relative maximum.
Local maximum. What about this point?
Relative minimum.
Local minimum. Oh.
Divided by minimum.
Okay, now what about at the endpoints?
They don't count.
Yes, they count.
No.
Compared to points nearby, isn't that the lowest point? So this endpoint is also a local minimum. What about this point up here on the endpoint there?
Local maximum.
That's the absolute maximum because that's the highest point on the entire graph. Okay, so it's easy to see when you have the graph in front of your face, right? But we have to be able to find all these points without drawing the graph by using calculus. Now I want you to notice something. Where do maximum and minimum points occur?
Vertices. No.
Like for example,
Oh, when the slope is
when
zero.
the slope is 0, right? What about here? The slope is 0. The slope is 0. Well, what about here? The slope is not 0 there because the graph comes to a sharp point.
Or when it's not differentiable. Slopes are equal.
Okay, so we can find maximum and minimum points when either the derivative is 0 or it doesn't exist, right? We call those points critical points. This is an important word, you know. A critical point is a point where the derivative is either 0 or doesn't exist. Now, just because the derivative is 0, that doesn't automatically mean you're going to have a maximum and minimum there. Yes, I'll give you an example later. But a critical point will give you a possible maximum or minimum. Also, endpoints are critical points as well. So if they restrict the domain on you, then the endpoints would be maximums and minimums. Okay, so let's look at a problem. No, before we do the problem, I guess I gotta state theorems, yeah? If the first derivative is positive, what does that mean? Here. If the first derivative is greater than 0, let's just write it like that, positive, that means the original function is what? Oh, how do you know? Who said that? Is that econ? That's not econ, right? Just think about it. If the first derivative is positive, which means the slope is positive, that means the graph has to be going uphill. The function is increasing. Chen! If the first derivative is negative, that means the function is decreasing. Oh.
That's what I said. Good morning, back.
Okay, so we're going to use these two things here to figure out maximums and minimums. Okay, so here we go. So let me give you a function, yes.
What if like at the end, like if they restrict it or something, and then the endpoint is like after a horizontal line? Is that?
Oh, you mean you have a graph that looks like this? Oh, boom, like that.
Yeah, like at the end. Is
then all of these points here are all absolute maximums. Because all of these points here are the highest points on the whole graph, right? So you have an infinite number of absolute maximum points. Yeah, that can happen. Okay.
Will that happen on a test?
No. Okay, so f of x is equal to x cubed minus 3x plus 2. And I'm going to restrict the domain to be between -3 and 3. Now remember, when you have n points, those are going to be critical points as well. So the first thing you need to do is compute the derivative. Now come on, we know this is a cubic function. It looks like this, right? Right? Except we restricted the domain. So first thing, compute the derivative, which is, this is easy, right?
3x squared minus 3.
Okay, now what we need to do, we need to know when the first derivative is positive and when it's negative. So what we need to do is we need to factor it and make a number line. But this one is easy. Factor out of 3, completely factor it. And like I told you before, now, I don't think I took off points, but now, if you have a number line and it's not labeled, automatic -1 deduction already. Because I'm telling you, on the AP exam, if you have a number line that's not labeled, then we don't even look at it. Because this is part of your supporting work. And if you don't have a number line, that means you're going to have to write a paragraph, which I know you guys don't want to do. So you guys should get into the habit of labeling every single number line that you write. What goes on this number line? -1 and 1. And how do I know it's going to be plus minus plus?
The leading coefficient is positive.
Yeah, because if you were to graph this, it's a parabola opening up, right? Above, below, above. Or if you don't know anything, just plug in a number bigger than 2, bit 1, like 2. So you get 3 times positive is positive. And so forth. Think of a number between -1 and 1. 0, plug it in. 3 times 1 times -1 is negative. And so forth, right? So if you have to resort to that, whatever, but you got to get that number line correct. Now here's the part you need to write. You have to show them that you know the connection between the first derivative and the original function. So what did we learn? If the first derivative is positive, what does that mean? F is increasing. You have to write that. Otherwise, you're going to have a paragraph over here. Since the first derivative is positive on the interval from -infinity to -1, that means f is increasing. Why do you want to write that? We can just show it on a number line. If the first derivative is negative, what does that mean? F is decreasing. See how I write it like this? Now, most people across the nation, they're just going to write f is increasing, just like that. But if you write it like this, see, it's a visual thing. No, you're going to see how useful it is. From 1 to infinity, the first derivative is positive. That means f is increasing. So you can clearly see from this number line, where does the maximum occur? At -1, because the graph goes up and then it goes down. You can see it right there. Where do you have a minimum? At 1, because the graph goes down and then it goes up. There's a minimum there. Okay? Now, are these absolute or local?
Local.
So you don't know. In fact, you know what? I'm going to change my mind. I'm just going to restrict it from -2 to 2. That'll make it easier for us. Okay, so this is what we got. We got a function that's going up, down, then up. So we know we have a maximum at -1. How do I figure out the y-coordinate? You plug it back into the original. The original tells you the y-coordinate. Can you guys do that? That's why I changed it from -2 to 2 instead of -3 to 3, because I had trouble plugging in.
4.
If I plug in -1, you get -1 plus 3 plus 2, which is 4. There's a minimum over here at 1. How do I find the y-coordinate? You plug it into this. So you get 1 minus 3 plus 2. 0. But we have endpoints. Those endpoints are going to... Now think about it. The endpoint at -2 is going to be over here somewhere. So you have a point, and then it starts going uphill. So what do you think this point is, a max or a min? It's a min, right? Because it's the lowest point compared to points nearby. So we have a minimum at this endpoint. How do I find the y-coordinate? You plug it back into the original, and you get -8 plus 6 plus 2. Oh, get 0. And then, at this endpoint, at 2, right over here, So the graph goes up and then it just stops. Is that a max or a min? That's a max. So we have a maximum at 2 comma something. How do I figure out the y coordinate? You plug it back in here and you get 8 minus 6 plus 2, which is 4. Whoa, they came out the same.
So you got 2 f's.
Okay, so what's happening in the graph? So basically, like I told you, it's a cubic function, except we're restricting the domain. So it kind of looks like this actually, yeah? So there's a minimum over here, -2, 0, then it hits the max, and then the min, and then the max right there. So how do you classify this point right here, this endpoint? Is that a
Absolute.
local or an absolute minimum?
Absolutely.
It's the absolute minimum, because, how do you know? Because this minimum and this minimum point both have the same y coordinate. So they're both absolute minimums. Both of them are the 2 lowest points on the whole graph. I didn't want it to come out like that, but it just did. Too bad. Okay, what about here? What about this point and this point?
Absolute.
They're both the highest point on the whole graph, so they're both absolute maximums. And that's how you tell. You gotta compare the y coordinates. Whichever one has a bigger y coordinate, that's gonna be the absolute. The other ones are all local, right? And that's what you have to do in every single problem. It's quite simple. All you have to do, take the derivative, make a number line, just like this now. You have to have every single element I have here. If you don't, you gotta write a paragraph. Like a lot of students, you know what they do? This is what they do. They go, oh. Now you can do that, except you gotta explain what that thing means. So if on your paper you have this means f is increasing, and that means f is decreasing, then you can do that.
No, but yeah, the AP.
Yeah, so as long as you have a legend. And you gotta be careful, you know, because too, what if you did this? See, some students do this, they go, oh, y is increasing, y is decreasing, y is increasing. You might get points taken off, you know why?
It might not.
There's no y defined in this problem. Where do I see y?
Would you have to write y equals f of x?
Yeah, but why not just put f like you're supposed to? You guys know what I'm talking about? Because later on, we're going to be making number lines. You're going to be saying, well, what's the big deal? Because we're going to be making number lines for the first and the second derivative, and you're going to have more than one function here. You're going to have f and g. So you have to be very specific when you make your number line. Okay, so tonight's homework, what are we doing? All we're doing is we're trying to locate, the book calls it extrema. You know what extrema are?
Nope.
Maximum and minimum points. That's what we're finding. Extreme values.
Why don't we just do min-max? It's called min-max.
Okay, so it's pretty easy. Probably the hardest part for you guys is making the number line. That's my guess. Come on, the calculus part is so simple. Everybody knows how to compute derivatives, right? But now we're going to do a number line. Okay, so that's the lecture. Okay, let me pass out the test.
Was that recorded?
Yep.
Already.
Because we have some people not here. They requested. But like I said, I think we just might record it from now on. Oh, it just barely fit in.